And this is it. Woo! Finally made it live. Had some trouble with a USB hub, which very much doesn't like to play nice. Yep, we are in fact live. Fantastic. Alright, well, I have a few ideas for today. Although, I thought we'd just kind of see what happens really, so fingers crossed everything stays working this time. How's it going, Chris? Nice to see you. Nice to see everybody here. Yeah, so yo, Dominic, all right. Had a few ideas. I've been bugged for a long time by somebody from the postmarketOS community to check out box 86, or there is apparently an equivalent for oh, here we go, for x64 called FX, which probably won't show up on a Google search, but that's okay. All of my applications are opening on the wrong monitors. Right, before we do anything else, let's make sure that everybody knows that we are live, because that's very important. I seem to have lost the stream. Okie dokie. There we go. Fantastic. So let's start off by taking a look at FX. Apparently you need to set up a root FS. My USB hub is broken again. It might be this it might be the webcam I'm using, or rather phone I'm using as a webcam. The phone cam has died. Let's see what we can do about it, shall we? Phone cam's better than face cam. So let's see. Don't worry, it's not frozen. Does look mighty frozen though. I think it just, the whole USB controller just kind of Perhaps itself. This isn't how we want to start a stream, is it? Oh. Well, might have to reboot the PC again, because there doesn't seem to be really any other option. Starts with this hub external port status failed, and kind of goes downhill from there. Yeah, I think it's to do with USB auto suspend, but who knows? Because I sure don't. Well, we'll take a short interval. I'll reboot my computer again, and we'll not use the USB hub this time. All right, I will be back. Well, yep. Okay, we're back. Ooh, no USB hub. So we should be fine. These are all good. That's just my webcam being a bit shit. Fantastic. This webcam is actually a Raspberry Pi 4, but that is possibly a topic for a different stream. All right, let's get this out of the way so it isn't confusing. And yeah, okay. There's too many things going on here at once, really. A little bit overwhelming, but it seems we are good. We will make sure exposure lock is turned on. Yeah, I've got a Droid Cam on a phone for this view. But the resolution is not great. It's going over ADB, and then the webcam is a Pi 4, and it's like it does up to 1080p, although it crops the sensor for that, which is not ideal. Great. Let's figure out why all my terminals are open in full screen. It is really, really annoying. Okie dokie. Right, this phone was plugged into the dock, so we'll have to plug it into the back of my keyboard. Oh yeah, I hate the Droidcam isn't free software, but hopefully libcamera and UVC gadget will save us from Droidcam at some point. And still nothing. Oh, failed. This really is Murphy's Law. This is I've absolutely never plugged the phone in and had the Ethernet gadget fail to probe. We'll try again, shall we? Alrighty. Now then, should we use Fosh? Or should we make a new rootfs? for facts. So we're going to be running like games on an x86-64 compatibility layer. So it's going to be using X. Do we want to deal with Wayland and X Wayland on top of dealing with? Yeah, I don't think we do. Here we go. Phone is up and running. Yeah, why don't we start with something a little less out there? So currently, you will see that the current version of this kernel has not really a bug, but it's an issue that I fixed last stream actually, where the haptics cause this false error message every single time. So we fixed that last stream. You can actually, we can go and look at the merge request. Here we go. Fix haptics busy error. So we basically just rewrote this is haptics idle function to not do this weirdness where it was like retrying. There was no sleep, but yeah, compiling facts on Alpine. I don't think I have a Manjaro ARM rootfs to hand at the moment. There it is. I think I deleted them all to make space. So yes, chroot could work. Right. Well, I think we should start by updating the kernel package. So for those of you that don't know, look, this encryption is being done on the CPU, I think. It's just using like dmcrypt. Which implemented as a device mapper target. Yeah, so is done on CPU, which is a shame, but it happens in the initramfs. So yeah, I'll be honest, I don't know enough about encryption and like how to make that all properly secure to tell. I do know, however, that whilst Qualcomm has hardware encryption engines, they are proprietary. So FDE and dual booting Android, I would not suggest it. That isn't correct at all. You can do it. The current only way to have full disk encryption working is with the postmarketOS stock initramfs, which, you know, they've put so much effort into getting that stack working, like being able to boot up. So when you turn the phone on, that screen that you saw with the where you type in the decryption password, not only is that running with OpenGL, it also has full hardware acceleration. So the initramfs contains the graphics, the GPU firmware, and the Mesa libraries, and it boots up the GPU and like initializes the whole display to do hardware accelerated rendering, so that you get this nice UI. It's an impressive amount of work. The problem with the postmarketOS rootfs is it doesn't support using like an exe4 image. Not the rootfs, the initramfs. So my postmarketOS builds deploy the rootfs as an image on user data, and then it mounts the user data partition and then loop mounts the image, and that way you don't have to lose any of your data. However, on this device, need to make this font bigger, don't I? Currently have to use a partition, and on the OnePlus 6, you have like the system partition, which is 3 gigs, the vendor partition, which is I don't know actually. I think it's smaller. In fact, let's find out. Dev disk by part label vendor B. Vendor partition is only 500 megs, so you're a bit screwed there. So you have to use a partition, and the only one that actually gives you any leftover space afterwards is the user data partition, which obviously means that you won't be able to boot Android, because you wouldn't have user data. So yeah, kind of a downside, but at the end of the day, if you're using full disk encryption, you probably wouldn't want to be using Android anyway, if that makes sense. Like, you're using the phone with full disk encryption, so like you want your data to be secure. You'd probably have a locked bootloader, but yeah. Oh yeah, there is MSM 8996, the UFS ICE is mainlined. I think it might be the same for STM845, but I'm actually not sure. We could take a quick look. But first, let's go edit our config and make the font size something readable. 18. Whoa. There we go. That's a little bit better, huh? A little bit better. Fantastic. Okie dokie. So, yeah, let's go. We've got another week until 5.12 lands. So, yeah, it's not really worth updating the kernel, is it? That sucks. Well, we could and possibly should still. Oh, where's. Alright, my VS Code window share is not very happy. Let's fix that. Hello. Not very happy at all. There it is. Alrighty. Oh. That'll do. Streaming on a 4K monitor is probably not ideal. Turn up the font size a bit. Terminal. There we go. Alrighty. Hopefully this is nice and readable for you. So yeah, let's head over to the enchilada kernel and see what's going on. So where are we? All right, I have this 5.12 kind of work in progress branch, so we can start by trying that out. Yeah. it shouldn't take too long to build. So currently with the OnePlus 6, the major bugs that kind of need to be dealt with are audio, which is a real pain to work on. In the past with audio, I've had inconsistent behavior across reboots, which is very bad, and yet to find a reason for it. So last time I tried it wasn't so bad for the most part, but yeah. I thought I had the headphone jack and earpiece working. The headphone jack and earpiece actually use the same like multimedia node. Is it in this branch? Let's see. Well, I hope the stream's doing okay. We're compiling a kernel at the same time. I don't think it is. That's right. Yeah, they use the same like audio output. It goes to the headphones and the earpiece, and it uses some weird switch to kind of switch between them. But we could not figure out how that behavior actually works. So sometimes it would only come out the earpiece, sometimes it would only come out the headphones, sometimes it would come out of both, and sometimes neither. So it's yeah, audio is a bit of a mixed bag. I think we'll kind of try and get headphones working explicitly without the earpiece and go from there really. The speaker will require a driver, which on downstream is part of this big audio driver package called Tech Pack, which I expect some of you will have heard of, but I don't remember the details. Oops. Well, that ain't very good. Yeah, so fantastic. This one is just a stub. Okay. Yeah, so the speaker driver is part of TechPack, which has all of its own like frameworks and stuff. And it adds itself as an extra like folder in the root of the kernel tree. So extracting the speaker driver from that is not going to be too fun. Kind of been putting it off for a long time at this point. So yeah, audio is one thing. There is a larger underlying bug, which some of you will have definitely encountered if you've tried postmarketOS, which is the random crash dump reboots. Those seem to have a few causes, but I think when you get down to it, it's actually the same thing, which is there is some memory address or region somewhere which we aren't reserving, which we should be. So in STM845, you can see all of these reserved memory regions. So these are all areas of memory that are used for like loading firmware or used by other processors. For example, the like the camera, the ISP, used by the GPU, various remote processors here. And there's this RMTFS mem, which is put here by default. And this is like most devices are fine with this. For some reason, the downstream driver, yeah, this has its own driver. The downstream driver for this does not give it a fixed memory location in the device tree. It's instead read from firmware or read from some like read from the modem and allocated that way. So on the OnePlus 6 at least, let's go find it. It is over, I think I tested like 2 or 3 reboots. It was always given this memory location, which is completely different to the default here. And that's kind of it. Exactly why, I'm not sure. Reserving the old region that's allocated here seemed to help with a few crashes. I've been through like all of these regions with a fine-tooth comb and I couldn't find any like gaps, unfortunately. So that's it. To the best of my knowledge, all the memory regions that should be allocated are reserved, sorry, but it still crashes sometimes. It always crashes just after the modem boots, just as I imagine the Wi-Fi like hardware or whatever is booted up. And yeah, it's really hard to debug. So I have also encountered it when copying very large files. For example, the other day I was trying to boot some like the Fedora AS64 rootfs, which is about 7 gigabytes. So the phone was running postmarketOS, so I thought, well, that's fine. I will just copy it over SSH. And at about the like 4.5, 5 gig mark, it crashed, went to crash that mode. So I thought, well, that's odd. Let's just try again. And the same thing happened again. So I ended up using ADB. But what that points to is that as the file's being copied and it's using memory to buffer that copy, it's a lot more likely to go touch memory that it shouldn't. So it seems like the only way that we're going to debug these crashes is to do lots and lots of memory allocations and log all of them and find out when it crashes. And eventually, with enough data, we can like draw it and we'll be able to see. So you can imagine like all the memory. If we just color in all the bits we allocated and then look at the ones that we allocated just before a crash dump, then color them differently, then we should start to see a pattern and we'll be able to see what regions are causing crashes. I would expect that there are tools for that. I'm not sure where to find them. I haven't done much more research into it other than kind of figuring out that that's probably the right approach. But yeah, that seems to be it. The alternative, of course, is that the modem just gets unhappy sometimes, which won't be so easy to fix. I'm not really sure quite what we'd do in that case. It's probably something that the guys at like Linero would have to look at. So yeah. Oop. Wonderful crashes. That's kind of the issues that really need to be resolved now. We also need to get IPA working, which is the packet router used by the modem it's basically, it shuffles packets around and network packets. So we need it to get mobile data working. So I think that that will need to get done. But for now, I'm waiting on the modem manager merge requests to kind of get a bit cleaner. So there are some open merge requests to modem manager which add proper support for modems connected via QRTR, which is the like Qualcomm router protocol. Basically, it's Qualcomm model all the remote processors, or not model, but like literally kind of implement the communication between all the remote processors as a local network. I suppose it would be a root network. So if we go connect to the device, I can run this. Oh, you can't see this. There we go. Oh no. So yeah, so there's this QRTR lookup command. So this shows us all of these services, and they are all running on node 0 because, never mind, that's just not true. Node 0 is the modem, I think. You wrote down a list of questions? Sure, hit me. You can always ping me on Discord or Matrix and ask questions there if they're kind of big ones. That might be more sensible, but yeah, go for it. Right, so yeah, the modem is on node 0, and these are mostly services that are running on the modem. So for example, like location service, the WLAN firmware service, which is the service responsible, I would presume, for loading the Wi-Fi firmware and configuration. So QRTR is the name server. Originally, it was implemented as a user space application, QRTR. However, given that actual like kernel drivers and stuff were dependent on it, they ended up taking the route of integrating it into the kernel. So the kernel has QRTR now, and it implements all this stuff inside the kernel, rather than as is QRTR NS. What's QRTR CFG, huh? Not spotted. Damn. Yeah, so QRTR is the kind of the name service, literally what it does. Then on the user space side to handle stuff, so for example, the modem is responsible for booting up the F10K WLAN. So it has this firmware service, and this basically goes like, hey, I need firmware, and we need to be able to listen for that. So there is this other daemon called TQFTP serve. Ooh. Right, it's literally a FTP server that runs on Qualcomm's the like key router, whatever. So the logs aren't stored, unfortunately, otherwise I would show them to you, but basically it's just it's basically the equivalent of TFTP, which anyone who's net booted a device like a Raspberry Pi would be familiar with. So the modem goes like, hey, I want this file, and it serves the file. So it serves the Wi-Fi firmware and various other configuration files to the modem, and it boots up the Wi-Fi. So yeah, there's like the remote processor subsystem is quite hefty and capable of doing lots and lots of things. So when it gets unhappy, you're kind of in trouble. It's possible to get rid of these. It requires firmware modification. I tried it before and it didn't seem to work, so I kind of gave up. If anybody is really annoyed by it, you can find the instructions on how to do it and open a merge request to the firmware repo to replace it. So yeah, we have this error, which is probably worth looking into. You know, I think it's very important that we find the GPU cooling device and make sure it's hooked up properly. And I was looking for the remote proc start. This is new, relatively new. I haven't really seen this a whole bunch before. Yeah, so that's mostly it. I have previously looked into the DSPs. So we have an adsp, which is responsible for audio and can do other things too. And then we have a cdsp, compute DSP, which is primarily meant for running like hardware accelerated neural networks. And I remember seeing a GitHub README or a wiki page, I think, ages ago, which was literally instructions on how to bypass the Qualcomm DSP like checks. So you're only allowed to run signed code, of course. So there's a way to bypass those checks, at least on the Dragon Board 410, and run your own like TensorFlow models, which is really, really awesome. Certainly for this. So yeah, being able to do like TensorFlow on dedicated cores designed for it, very cool. And given that the DSPs are just kind of idling otherwise, it feels like a waste not to really. Yeah, so we have an error in our kernel build. Ooh, here we go. If we just run the build again, then it will just tell us the error. Fantastic. Murphy's Law strikes again. You know what, let's do a full on nuke the build directory. Here we go. Yeah. I think there is some interest within postmarketOS in using kernel config fragments. So for the kernel config that we have here, we use the ARM64 def config, which is updated by ARM64 maintainers, and we use that as a base. So all the common stuff that you need for an ARM64 device is all in here, as well as lots of like stuff builders modules to support many boards. And then in here we have this scma45.config, which is a config fragment. So you see when I run the make command, I specified the def config and then the config fragment. What it will do is any options in here, which are also in the def config, will be overridden. So all these ones that are commented out, I believe, no, because they're commented out by set to white. I think those might be ignored. But many of these, so for example, all of these architectures that we don't care about because none of these are Snapdragon 845. We disable them all just to speed up build times. And then up here we enable Pocophone F1 and OnePlus 6 specifics. So, for example, the panels, touchscreens, all that kind of stuff. We build it all as modules. So in the same fashion as the normal def config. If you build a kernel with this, it will have modules for like the hardware that's shared by both. And for the hardware that's device specific, it'll have modules. So you deploy the modules and you're good to go. So this kernel works on the OnePlus 6 and the Pocophone F1, which is super cool. And then that's it, really. So eventually it'd be nice to get some other Snapdragon 845 devices going, because realistically it should be quite easy to get pretty much all the same stuff working. I believe the Mi Mix 2, somebody's kind of working on it. Would be cool to see how that's going. Ooh, this shouldn't be built in. I think we built the panels in because we wanted to get the display up early so that we can see the message, and it's just a bit easier, really. If you build it as a module, then you don't get anything on the screen until after you've mounted the rootfs, which makes debugging a bit of a pain. So yeah, it's also a bit of a nicer experience for the end user to be able to see stuff actually happening, which is of course the end goal. Here we go. It built properly the second time. I will run this handy dandy but really horrible alias, which goes and deploys modules to the device. So right now it's using rsync to copy them all across. Then it will SSH to the device and copy the modules into lib. So now that they are deployed, we built a kernel. So now we need to make an Android boot image. However, I did not consider this. So we're using the stock postmarketOS initramfs, and we need to keep using it. Otherwise, yeah, it won't boot anymore because we have full disk encryption. So let's what's the best way to do this now? Dev disk by part label. Ooh. What slot are we on? I think we're on slot A. So what we're gonna do is we are going to grab the boot image, extract it, replace the kernel, and flash it back. So Arch M64 Z image, not the iPod. Spoilers. Estimate for 5, OnePlus, enchilada. Z emit, no. Cool. We have aboot img. I wonder now, can we run aboot img directly on the dev disk by part label boot a dash, I think we want dash k. Yep, Yes, we can. Fantastic. Oh, look at that. You can watch the phone reboot and everything. If it gets there. It is possible that it will just crash, as it likes to do that on shutdown too. Rsync is great. Getting this in the getting what in the 1 terabyte variant. Which parts of Android are left on the device? I'm not sure. Can you explain in 2-3 words which parts of Android are left on the device and which parts are used? I'm not sure I understand. Do you mean in terms of like the partitions, or like which ones do we need to touch for postmarketOS? We seem to be stuck on a black screen. Whoop, whoop. Okay, so the way that postmarketOS works for Android devices, or I guess the way that Android devices work is, well, specifically Qualcomm. So everything I say applies to OnePlus 6. It may or may not apply to other devices. If your device has the same SoC or a similar SoC, then it probably will too. So the boot process is relatively straightforward. We can grab a diagram of that. There's one for MSM 8996 that floats about, but it's basically the same for us. So this isn't it. I think it's, here it is. Is it in here? Oh, this'll do. So yeah, so there is a primary bootloader, which is like super low level. It's flashed into read-only, like into ROM. Nobody can touch it. It starts turning on the hardware essentially. Then you get a like secondary bootloader, which, so you know when you turn your phone on and it vibrates, I believe that'll be implemented in there. It boots up the hardware, kind of does some initial checks and like boots up the CPU core and that kind of stuff. I think. And then you get to the on Qualcomm devices, the XBL or extended bootloader, which initializes the display on MSM 898 or Snapdragon 835 and newer. It's based on EDK2, which is an open source UEFI bootloader, or bootloader capable of UEFI. Hence why there is EDK2 development for Snapdragon 845, because it's possible to extract blobs from the device and use them. Anyway, that's a different topic entirely. So the XBL contains drivers for display hardware, buttons, charging. It can do haptics, so it can do I2C. It can even technically do touch, but that's never implemented. So right now here in Fastboot, we are running the Android bootloader, pboot. Kind of. No, that isn't true. Pboot is what's used on like devices that use the LK or little kernel. XBL just has a Fastboot application that it runs basically. So here it's running fastboot. It could also be running like UEFI shell or whatever. It's implemented in the same way. So there's this fastboot application which is running, and it does all the USB stuff to show up on my host as a fastboot device. During a normal boot, it doesn't launch fastboot. It'll only do that, if you're holding the volume buttons or whatever it is for your device. During a normal boot, it will detect that you aren't holding the volume buttons, so it will go and read the boot image. So on Android devices, I suspect that the boot partition is either marked by a flag or it just hard codes the offset because they can. You aren't really meant to repartition Android devices. So that's why if you've repartitioned the device, you can permanently brick it, because the bootloader, which is locked, tries to read it, read the boot partition, can't find it, and you're screwed. Sucks. So yeah, XBL reads the boot partition. The boot partition, as you probably know, contains the kernel, a RAM disk, DTBs sometimes, depends on what version of the Android boot header you're using, and a kernel command line. The bootloader will then do what any normal bootloader does. It loads the kernel into memory, loads the initramfs into memory. Android bootloaders on new phones have a DTBO, which is another partition, which contains a bunch of device tree overlays, which the bootloader may or may not overlay. That's completely vendor specific. So yeah, most Android devices use an appended DTB, and the bootloader will read the appended DTB, overlay on it if needed, and yeah, put it in memory, and then it jumps to the Linux kernel in the standard way and tells it where the DTB and initramfs are. The kernel boots, loads the initramfs, unless you're running downstream, in which case, if your device is system as root, then it will skip the initramfs, unless you're booting into recovery. And that's it. You're now in Android or Linux or whatever. You're running a kernel. So downstream Android will boot up on the OnePlus 6, which is system as root. It'll mount the system partition, which it looks for by name, and yeah. Or the bootloader sets. I actually don't know the details there, but it mounts a system partition somehow, and runs it in it there, mounts the vendor partition, kind of puts it all together, and that's it. You're running Android now. So that's all very well. On postmarketOS, the process is pretty similar, a little bit different. So the thing that we're stuck with is the stock bootloader. We cannot touch it because it is signed, and even if your device is unlocked, the primary bootloader will refuse to boot it if the signature doesn't match. That's one of the things that the primary bootloader does, is validate signatures. So we're stuck with whatever quirks the device has. So if the bootloader does really weird crap on the command line, that's it. We have to deal with it. There's no other way around it. So luckily the OnePlus 6 is quite sane, and we can take a lot of shortcuts. So the DTBO partition, which contains a lot of well, device tree overlays, various bits and bobs. In fact, most of the device tree for the OnePlus 6 is not stored in the device tree appended to the kernel. It's stored in the device tree overlay partition, the DTBO. So if the kernel appends the downstream DTBOs, then Mainline Linux will not boot. It is not very happy with them at all, for obvious reasons. So the driver compatible lines are all different. The CPU configuration is named differently. I assume the bootloader part can't be replaced if we had an alternative. That's correct, yeah. So the bootloader is signed. The keys are flashed onto read-only memory, I think. I could be wrong about that. But yeah, those keys are kept safe by Qualcomm, and we cannot do anything lower level than the boot partition without those keys, which is a real shame. So yeah, on the OnePlus 6, fortunately for us, we don't want the DTBOs to be overlaid, so what we can do is we can just erase the DTBO partition. That's what I do, and the bootloader will read it, go, oh, it's empty, and not overlay anything and just continue booting, which is fantastic for us. On the Pixel 2 XL, for example, the bootloader is not so kind, and I presume for security reasons, not security, but probably more likely safety reasons. So the Pixel 2 XL, if you look at the kernel sources, there are like 5 different revisions, and I think the implication is that there are multiple different revisions which shipped to customers. So the bootloader for your hardware will, depending on the hardware ID, load a different overlay for your revision, and those revisions may contain fixes for like hardware bugs, for bad components or whatever, to make sure that your phone doesn't like overheat or a temperature sensor is blown or something. So if the bootloader cannot find the revision, can't find the right overlay matching your hardware ID, then it will just stop. Phone won't boot, you won't know why, and that's it. That took me a very long time to figure out. Eventually I did, and created basically a blank overlay with the correct IDs, built a DTBO partition, flashed it, and the bootloader was happy, and it booted mainline. Yeah, so that's that. Bootloaders do weird stuff, and we have to deal with it. Once we get the kernel booting, for example, on SCM845, we have like a frame buffer, which Android doesn't use, but the bootloader sets up the display panel for us. As you can see here, we're in fast boot mode. We're not running an OS yet, but we can see stuff on the display. It's possible in Linux to reuse that frame buffer, so that's what I use for early development on the device. And that's what's used. Well, actually, it isn't, but a very similar frame buffer is used when you boot up the phone currently. So in terms of Android parts that are reused, we're stuck with what we've got, but we have quite a lot of freedom. Well, not as much as would be nice. We are like limited in that we can't go messing with partitions too much. But yeah, I would point out that you can dual boot with Android. And get full disk encryption. So amending what I said earlier, it is possible to repartition the device somewhat. You can resize the boot partition, so you have freedom there. Not the boot partition, the user data partition. My bad. So the user data partition on my device is 128 gigs. Because of how the partitions are laid out. What are we doing? Oh right, we're in fast boot mode right now. Yeah, let's boot back up. All right, so because of how the partitions are laid out, you can shrink the user data partition and create new partitions next to it in the empty space. And that doesn't touch like boot, doesn't touch anything important, so it's totally fine. Of course, if you do this, it is entirely at your own risk because it is very easy to screw up. In order to shrink it, you have to delete it and recreate it. I did that in postmarketOS and I messed up, to put it lightly. I messed up and accidentally wiped the partition headers. So it uses GPT partition layout. This is a bit broken, I think. That sucks. Yeah, it uses GPT, and so every partition has a header. Android has its own custom headers just for Android devices, you know, as they do. And I lost the user data one. I could not figure out what it was because I couldn't find a table that said like what's what. So after a while, I eventually managed to resolve it, but yeah, the phone wasn't very happy when it couldn't find the user data partition. So that's that. Luckily, we always have mostly always have the MSM like download tool to fall back on, so it's not the end of the world if you brick it. You can like factory reset it from the primary bootloader. That's what MSM download tool does, but you probably don't really want to be doing that unless you really have to. So yeah, once you're in postmarketOS, you can kind of do what you want really. You're just kind of limited in that the kernel must be packaged a certain way, stuff like that. This article is quite a good read actually. Unfortunately, none of these bugs exist for us, but yeah, getting Firehose is good fun. Oh, that was probably a lot more in depth than you wanted, but there you go. I suppose we will have to make a new postmarketOS install now. Woo. We will use this terminal. Right, whilst this goes, I'm going to grab some water. Whoa. Yeah. There you go. We're ready. Quick break. Okie dokie. No Pinephone freedom. That is very true. Yeah, we're a little bit screwed. I loved seeing it's called pboot, I think. It's a really tiny bootloader for the Pinephone. No, not pboot. Pboot. I don't think you missed much. Lost 2 viewers. When I want to grab a drink, that's okay. Oops. This isn't it. This is random stuff. Pboot. Nope. Boot. I did say it was tiny, didn't I? There it is. Fantastic. It's really tiny. Yeah. Oh. Source. This is it. This is the whole bootloader. It has drivers for like all the important things. And it can boot things on the Pinephone. You flash it and like it's a bootloader. This is fantastic. And yeah, hi Martin, how are you? Pboot is so tiny. It stripped all the convenience features. Yeah, probably. It's nice to see. You give up convenience, but you gain speed. I'd say it's probably more convenient to use than an Android bootloader. But, you know, such is life. Alrighty. So, we've done the install. Just, you know, to reiterate how absolutely ridiculously simple it is to install postmarketOS. The fact that this phone already runs postmarketOS is completely irrelevant. You want to run postmarketOS on your OnePlus 6, you init, you pick OnePlus, enchilada, enable non-free because you want Wi-Fi, and yeah, you just go through that. You run install like I just did. And then you flash readfs. We want to flash the user data partition because if we flash the system, you will have absolutely no free space left. How do I know this? Well, not absolutely none, but you'll have about a gig. Maybe enough to play around with. But you know, if you want to go compiling stuff, you're gonna run out of space very fast. So after that, we flash the kernel and then fastboot reboot. These 3 commands, we run them. We reboot the device into fast boot mode. Fantastic. And that's it. Flashes, and it will just boot postmarketOS. There is one more step actually. Erasing the DTBO, which I've already done, so I won't do here, but fastboot, erase, DTBO. It is that simple. Yeah, developing for phones is surprisingly straightforward. And surprisingly easy to automate. Unfortunately, I don't have a way to like hardware reset this phone without manually doing the power buttons and stuff, but man, if I could and you know, spoilers maybe, find a way to have the battery on a switch and the power on a switch and control that from like a Raspberry Pi. wouldn't even have to be here. This phone could be somewhere else. Which is a cool concept. Linero have their Lada system for that, which is basically exactly that. It's a board farm. Very cool. Here we go. postmarketOS. PHP builds. Oh yeah, pboot does use the PHP build system. I found that hilariously cute, but I've also never used pboot, and so yeah, I was confused to see this the first time. Yep. One would question why you would write this in PHP instead of in Bash. Perhaps Martin can enlighten us. It appears we've encountered one of those wonderful crash dumps. This is the problem, really. There's no way to get logs. Well, easily. It's crashed. It's possible to dump all 8 gigs of memory in this mode. I have managed to do that before, but I couldn't track down the logs inside them. Which really sucks. Oh well. Yeah, so right here, it's using a frame buffer. That frame buffer emulation is set up by the mainline driver, not by the bootloader. It could be reusing the one from the bootloader, but I'm not really sure. Some things aren't really worth worrying about, you know? It's fun to see some people from presumably the Pine64 Discord here. Ugh. Yeah, there we go. We are done. Alrighty. So that's that. I think attempt to patch the boot image was not good. However, this new install is not using full disk encryption, so we can do this. Oh no. This isn't good. Absolutely not good. pboot.config. I suspect it's because it looks in testing. You know, there are always just so many bugs. There it is, look, you see? You reckon if I put an asterisk there, it'll work? Alright. To do. Yeah, so the OnePlus 6 is hopefully moving to the community device section, which is really exciting. That merge request is going really well, and that's part of the reason why I got full disk encryption working. So, you know, it was personally where am I going with this? No, well, the postmarketOS goals for devices, I think, are really good, and full disk encryption being one of them, kind of only makes sense to go support it. How's the weather in Wales, by the way? Apparently it was snowing this morning. My friend texted me and said, but I was asleep, so I didn't see it. That's all I have to say. It's gray but bright. Unbox soon. Unbox should work already. I haven't tested it in a little while, but it should work. I'm pretty sure that everything needed. Yeah, it's enabled. Go test it. It takes some setup. You have to get a root shell in it to add the IP route for like to get internet working, but it should work. Alrighty, so we need to make install modules again. I know this alias is horrible and should be a function. Right, so that mkb command, which is actually this shell script here, uses pboot configuration to grab all the needed arguments, and it uses mkboot img to build a boot image using my RAM disk, which it also builds as part of the script. You can go see it, see all the source code. It's all available. In fact, using my tools, it is possible to do a large amount of kernel development for devices like the OnePlus 6 without having to like go run tons and tons of commands. You run this, install dependencies as they crop up as missing. It's mostly pretty good at telling you what you need to do if something doesn't work. But yeah, I've put a lot of hours into writing these shell scripts. For example, this pmenv contains these make aliases. So for AX64 devices, you can just use this instead of make in the kernel, and it does everything. It puts it in the .output folder. You don't have to worry about any of it. You run make, and then you run mkb, which is just an alias to the shell script. You can specify anything if you want to, but you don't have to. Oh. And it will build a RAM disk, build a boot image using your pboot configuration, and you're kind of good to go, really. If your rootfs is just flashed to a partition, then you will need to specify, well, in fact, wherever it is, you'll need to specify some command line arguments. You can specify this rootfs part, which is the partition. SCA17 is the user data partition on my device. If the rootfs is a file on that partition, then you can also specify rootfs path as a relative path on this partition. So if it's in like just the root of the partition, then you just put like pmos.img or whatever. Or if it's in like .stowaways, which is where my installer puts it, it'll be there. That's it. You just kind of run this. It appends the DTB from your, this is fetched from your device info file. It creates an initramfs, and then it runs mkboot img and generates an Android boot image for your device. That's it. It's like, it's one command. It does everything for you. And then you can just go flash it. In fact, whilst we're at it, let's just enable Wi-Fi here. Don't need to show you all my Wi-Fi password. Fantastic. So now that we have Wi-Fi on, from this other script, which is over here, which does need a lot of work, but it exists. It's called automation, and this contains just a bunch of functions. So you source it, and then you can run these functions, and they're just shortcuts to do useful things. So at setup, which we can find here, copies your SSH keys, disables password or sudo commands on device, installs the reboot mode package, and then runs neofetch. Just, you know, need that. So now we can use the at flash command, which, I should zoom this in a bit, will call at to bootloader, which will up here checks the current state. There's lots of abstraction here. So this will check if you have the device in the device IP here. So if you have a gadget set up, then it'll return booted. If fastboot devices returns any devices, then it'll say bootloader. And if ADB devices returns, it'll tell you ADB. Otherwise, not connected. So yeah, so at to bootloader will get the current state. If we're booted, then it will do at reboot bootloader. This runs the reboot mode command on the device. True tells this function to wait until the device enters fastboot mode. So then when the device is in, of course, supports ADB2, it then gets the current slot, tells you the current slot. And that's it. We actually need to do this to get logging output, which I will fix at some point. So yeah, and then at flash will flash the boot partition and then reboot. So when we run it and pull it all together, runs reboot mode, the device should now reboot into fastboot mode. Eventually, reboot mode is a bit quirky. It does call sync, but you know, it doesn't do a very clean shutdown, but it's fine for development. Well then, that was it. Why are we at a black screen again? We've got a device here. It says probe failed. We don't have an IP address. Perhaps we can go here. I didn't just kill my internet, did I? No, that would be bad. Hello. Why is the password wrong? Oh boy. Oh dear. Something is very wrong indeed. Right, let's not worry too much about this then, and let's see what happens. Deep sleep. That's a good question. It's definitely not one that I could give you a very good answer to, because I haven't done too much research into it. Yeah, deep sleep is a complicated one because Linux basically doesn't do it in the way that Android does. So your Android device does some very smart stuff with wake locks and cool things which I don't fully understand. I don't know exactly what it does. Oh, there are some very loud seagulls outside. I don't know exactly what it does to the kernel, but your Android device keeps Wi-Fi on, for example, for a large part of the sleep period. That's how it's able to receive notifications. With always on display, that's the thing too. Android is capable of like shutting down some subsystems, keeping others up, which Linux is not so good at. So Manjaro ARM, for example, supports when you turn the display off, will go and go to sleep. Exactly like your PC would when you press the power button. It goes into suspend, so Wi-Fi turns off. Most of the CPU cores get shut down, except for one, and that's that. Wake locks are a thing. Is my microphone very quiet? Oh, I can turn it back up a bit. I thought I was a little bit hot, but there you go. So, yeah, deep sleep is a big question that will probably require quite a lot of work on the kernel side to get it working, as well as in user space to properly set up wake locks to support stuff like keeping Wi-Fi on or turning Wi-Fi on periodically. It's going to be quite a long time before it can compete with Android. In the meantime, postmarketOS, for example, will keep the device on and just turn the display off. Martin might be able to provide some more insight into exactly what else it does for power saving. But for example, in postmarketOS Flush, when I press the power button, the screen turns off, but Wi-Fi stays on, so I can still SSH to the device and everything. If I press the power button again, the screen is very quick to wake up. In Manjaro ARM, that is not so much the case. The whole device goes to sleep. So if you have an SSH connection open over USB, it'll get real slow and probably break. If it's over Wi-Fi, it'll die because Wi-Fi gets turned off. That's it. Now then, we need to flash our kernel again. Looks like we're going to be a bit screwed for kernel development today, but let's see. What does it do? This goes to a black screen. I don't know what that means. It's not what we want. Oh, I had Matrix closed. So that's not great. There we go. Yeah. Suspend? What do you mean suspend? Oh. Did I close my Chrome window again? I think I did. Okie dokie. Yeah, so getting full disk encryption to work was fun. postmarketOS, or PM Bootstrap rather, does a lot of caching. And that's great. It means that your builds are faster. It only builds packages that it needs to. However, it doesn't seem to be entirely predictable, at least in its behavior as far as I'm concerned. So I think probably a fair bit of this is my lack of like understanding in how PM Bootstrap does stuff. But yeah, getting into the workflow is a little bit confusing, and making sure that like if you make modifications to a package, to actually get that version of that package to be included in your build is a bit frustrating. But we got there in the end. Figured out how to get all the necessary files to get copied, so it wasn't too bad. Here we go. Oh no, wrong VS Code window. Cache gets PMA ports. Fantastic. Okie doke. So yeah, getting OSK SDL up with hardware acceleration. A lot of fun, really. So it's pretty much once PM Bootstrap actually uses the right version of the package, you basically just add this file, which is a list of the firmware needed for the GPU to actually boot up. So even though we have a frame buffer early boot, the GPU is not powered on. The frame buffer is driven by CPU, and it's just the MSM DRM driver kind of sets it up for you. It's neat. So we install that file to this special location, which means that when PM Bootstrap mk initfs runs, it will go and fetch these files from the device rootfs and include them in the initramfs. It's very smart. On top of that, once we have the GPU up, we need Mesa to do like talking to it. So we have this device info Mesa driver. There are Mesa drivers for every single like type of GPU. So Exynos, MSM, Sun XI for the Pinephone. I imagine there's one for like Power VR, all that kind of stuff. Intel, whatever. So you say MSM, then as part of the build, it will go and fetch the Mesa library from your device rootfs and include it in the initramfs. And all of that basically culminates in the initramfs being able to go, cool, we'll boot up the GPU. We'll run like OSK SDL, run it in OpenGL mode because we've specified a Mesa driver, so it knows to run hardware accelerated. And then when Mesa launches, it's like, hey, give me a GPU, and then the GPU driver is like, oh shit, and it goes and loads the firmware, and that's that. Yeah, so it's really cool. I haven't tried charging. What's it called? Charging-sdl. But I imagine it would. In fact, why don't we do it after we get I expect there'll be a bit of an issue here. So once we have all of this here, what we don't have is we are missing a kernel module. So let's go find the kernel package. Make sure. Linux postmarketOS. Qualcomm SMA45. Yeah, so our battery is a module. Fantastic. I actually don't know the name of the module. That's fun. Yeah, so I would also need to specify the charger driver module here so that it could get loaded. And then when you plug in the phone, but don't turn it on explicitly, then it'll boot up, and the boot reason or whatever, which can be read, which actually I'm not entirely sure. I think it's the bootloader tells us on the command line. So you can read the boot reason on the command line, kernel command line, and if the boot reason is like charging, then we boot into initramfs and display a charging animation. And that's it. So all that kind of nice stuff that you expect from Android we can get to, which is pretty cool. We should add that now. Yeah, that's what we should do. So let's just do a new flash. I don't know why the kernel modules are all gone. I think it's because I copied the 5.12 modules and it deleted the others, which is a bit of a shame. All right. We get to watch more flash. Well, you don't. Now you do. Hello. I'm afraid I would have no idea how to pronounce your name. But I am glad you are here and enjoying watching me flash postmarketOS again and again and again. Hopefully, last time. We should mess about on the phone really at some point. All right. We can actually go in here, output drivers, power. Here it is, PMIN8 FG. Fantastic. So let's go copy that over for Fajita and so yep, we will run pm bootstrap checksum device OnePlus enchilada and fajita. Oh, that doesn't work. Oh, yeah, we can't just supply multiple packages. Feature request. There we go. Now if you're on git status again, you'll see the APK build change. So pm bootstrap checksum just updates these down here. For those who don't know, if you do not run pm bootstrap checksum, your package will not build, unfortunately. So that'll be the reason why. We can run a pm bootstrap log over here, and then pm bootstrap build -- force. We're currently working on this branch, enchilada community, which is the merge request 2088, and it's kind of the we moved into community. We are also, oopsies, sorry, knocked the mic there. Also kind of cleaning up some stuff. For example, getting charging-sdl to work. So the Pinephone, which is probably like the kind of the best example, like what am I trying to say? It's kind of like it has the most features working. If you can match the feature set of the Pinephone, then you're doing pretty well. I'd imagine it has charging-sdl. I don't know actually. I think moving a device to community, it needs to be less about what we can do with it in terms of like experimental drivers and messing about with bits and bobs, and it should be more about cleaning up, making it work, making it a solid experience, fixing bugs that impact the user experience, and kind of just making it better. So full disk encryption is part of that, and so is charging. So we have built our device package. Bootstrap in it has this option eventually build outdated packages during Bootstrap install. Binary packages may be outdated. If you want to install postmarketOS without changes, reply N. So I had this set to N yesterday, which was very much a mistake. We 100% want this to be enabled. Otherwise, the binary packages which are stored locally will be used instead of building the ones from our own version of PMA ports. So we will zap chroots and install. We should go do some research into charging-sdl. I believe that's what it's called. Fantastic. Looks for specific options in Kernel Mainline. Awesome. So yep, it should just work out the box. With this wonderful script. Charging modes. LPM boot. Android boot dot Huawei type equals OEM RTC. Fantastic. Oh god. I've never ever had it on an oh yeah, the binary repository option. Yeah, it was a real mistake doing that. "17 people are here now. Amazing. Hello, Barlow HD. What are you currently trying to do? Right now, we are going to enable charging-sdl, which is a wonderful postmarketOS tool, sibling of OSK-SDL, and basically it's an implementation of a charging screen for your phone. So if you've owned an Android phone, older phones liked to be real quirky about how they do this, at least in my experience. If the phone is turned off and you plug in the USB cable, it will turn on and it will go to a screen which displays like a charging animation. So I always assumed as a kid that was implemented in like the bootloader. But it's not. It's an initramfs. So even on your like old Samsung Galaxy like S3 or whatever, when you plug it in, you get the charging animation. All of that is done in initramfs. So it's actually booted the whole kernel just to show you that animation, which I find kind of hilarious, but it makes sense, really. Is charging separate from fast charging? Depends on the device. On the OnePlus 6, fast charging is a feature that we probably won't get in postmarketOS because OnePlus use a proprietary fast charging implementation. So yeah, the fast charging driver is a binary which runs in user space on Android. The source code is not available. So somebody with the knowledge and time would have to reverse engineer that binary, probably like perform a man in the middle and see. It should be quite easy because the driver is there. The driver is open source. It just, because it's part of the kernel, it exposes an IOCTL to user space, which the real driver uses to talk to the chip. It is probably not that difficult to reverse engineer and re-implement something. However, personally, it's not really on my to-do list. Fast charging is nice, but I don't really care too much about it. I'd rather focus on the actual user experience, of which fast charging is not really like a top priority. Oh, charging-sdl sometimes crashes and makes the boot process continue. Love that. I guess we'll find out. So our PM Bootstrap install is done. So we can go and, well, you know what, before we do anything else, why don't we try running it from user space. Do we have it? We do. Yeah, we need to specify some handy dandy command line. I forget the actual environment variable that you have to set. Oh, thanks, crafty guy. Sorry, I didn't really read that before. PM Bootstrap config to change config options instead of running through init. Yeah, I will remember that one. Here it is, SDL video driver. Oh, cool. We have an option to prevent burn-in on OLEDs. Fantastic. Oh, I imagine that we need to, uh-oh. We need to stop TinyDM first, because that is currently using the GPU. Hey. Oop. Oh. Let me get you a bigger view of that. All right, let's run this again, shall we? I'm not exactly sure what that's. Is that the dash? Was it dash arrow moving that like? Yeah. So, oh, no font. That's a shame. Okay, so let's run it again with Dasho. I'm not sure if anybody caught it, but it does something a little bit strange. I don't know. Um, you know what? It's fine. We'll 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 forgive it. And the bootloader and the initramfs. Yeah, actually, the OnePlus 6, if it's really low on battery, then it will give you this big red warning screen, which says, "Hey, we're kind of dead," and it'll stay on that screen until it's charged sufficiently, and then it'll boot. Speaking of, I don't think it's charging at all right now because it is plugged into my keyboard's built-in USB hub, which definitely doesn't provide a whole bunch of current. Cool. So, once this is flashed, oh no, we don't want this fastboot reboot command. Ah, well. We will see what happens when we plug in a USB cable. Otherwise, we'll have to add the debug shell hook. And get a shell and test charging-sdl manually and find out why it wasn't working. I suspect that our OnePlus 6 will be kind and just use this. Alrighty, so it boots, yay. Let's shut it down. The thing I've always found quirky about the OnePlus 6 in particular, I think it applies to other phones too, just after the screen goes black, if you let go of all the buttons, the phone is now off. If you hold it for like 50, 100 milliseconds longer, then the phone will turn back on again because you're holding the power button, which is obviously like not that great. The time window to let go is really, really tiny. All right, let's see. Obviously, fun watching postmarketOS load just to go to charging. Well, hey, this is something. Charging mode, error starting charging SDL. I wonder if we have telnet. Oh dear. Makes sense. Makes sense. I was going to question why it would not automatically go into debug mode on a failure like this, but that would be rather terrible, wouldn't it? So hypothetically, say your phone gets stolen, and occasionally when it boots, something like this happens, charging SDL fails, and it's configured to just go into like debug mode so that you can go find out why. That means that if somebody stole your phone after enough reboots when this fails, they could just plug it in and they've got a root shell now. Not good, eh? It's really, really cool seeing like the security efforts that have gone into this. postmarketOS is, yeah, definitely taking those steps, which I think is really awesome because it's something that a lot of people overlook when it's just like, whoa, we got Linux on his phone, do all these like cool things, but at the end of the day, the aim isn't to like run Linux on a phone. It's to like be able to use a phone that's running Linux. And if it's got dumb security holes, like when it crashes, it just gives you a shell. It's not fantastic. Oh, hook add debug shell. Getting charging working, you say. Well, charging already works. Prawn. Charging already works. TWRP requires a login to enter the shell for later versions. Interesting. I'm not quite sure exactly what you mean by that. I know it requires your encryption key to decrypt your user data, which makes sense. But a login to enter the shell, like what would that login be? Why would it be stored? Because, you know, at least on TWRP 3.5, I can just adb shell and it will give me a root shell. Here we go. Oh. I think my favorite thing about getting OSK SDL working is that haptics work. The keyboard has force feedback. I think it's absolutely fantastic that took no work. The second I got everything shown up, you type your password, phone vibrates. You know, like it's so fantastic seeing that after all this work is getting done, that actually like we're implementing interfaces which are used, like haptics. Yeah, it's good. It's good to see force feedback being used. Doomsdayers, I think you are referring to the decryption key, which you get prompted for when you first open TWRP. It's possible to just click on skip, and then you're in. You can get a shell. You can't read the data, of course, but you have a shell. Which means that you could just erase the phone and use it. So, yeah, wiggly dots, absolutely. OSK, wiggly dots. I did have a little smile when I saw that. All right, debug shell is active, so we can do this. We can run charging-sdl. Oh yeah, of course, we need to set up the initramfs. So end goal for postmarketOS on the OnePlus 6. Once we have this, once we're in the, once we're a community device. Oh my god, the buds. Once we're a community device, then. All right, I'll shut the window. I'll shut the window. 1 second. All right, as I was saying, so it'll be possible to get pre-builts done for the rootfs and boot image and kernel, which is very cool. Means that as long as you don't mind being stuck with, you know, the default password and having to change it, which is a bit of a pain, but it's really not the end of the world. It will be possible to just kind of install it. However, currently, in order to do that, you need an unlocked bootloader, which means that your device is inherently not secure. So currently, all of the phones that I carry around with me have unlocked bootloaders, which means that if my phone gets stolen, then somebody can just erase everything on it and like go use it. And that's it. There's nothing that stops them from doing that, which is great for debugging, but not great for a phone that you carry around with you, unfortunately. So luckily, there is a solution to that. The OnePlus 6 and other modern Android devices have a VB meta partition, which is used for Android verified boot, which is enabled when the bootloader is locked. So what that does is it requires that the boot image is signed, and those signing keys, the public keys that is, are stored in the VB meta partition. The bootloader will verify that the boot image is good and has been signed, the keys match, and then it will boot. If that is not the case, then it will not. So what that means for us is, in theory, it's possible to set up signing keys, and as part of the build, we sign the boot image. Then as an end user, you would unlock your bootloader, flash a custom VB meta with the like postmarketOS or whatever signing keys, relock your bootloader, and flash postmarketOS as normal. Then you have a full chain of trust. Like, yeah, you have a root chain of trust, you have a locked bootloader, your device is like secure. If someone steals it, they can't get into it, they can't flash a custom boot image. If they erase it, I'm not sure if you even can do that. I would presume so, but yeah, if they erase it, then it's still a brick to them. They wouldn't be able to flash Android on it and do what they want, which is cool. Really cool. And I can see it being totally possible to make use of the fact that, for example, this device is an AB device, so it has 2 slots. So we could theoretically have like rollback updates or rollback like capable updates. So as a downside of having to, the requirement that the boot image is signed, that means that kernel updates would have to be shipped as a whole boot image, which is a bit of a pain, but I mean, it's still better than how Android does it, right? Yeah, chain of trust up to your kernel. That is true, but it means that you're protected from like a physical attacker for the most part. If somebody gains remote access to your device, then it's decrypted because you're using it. You can kind of say goodbye to your data, like they'll have your data there, but at least if your phone is stolen, it is still encrypted, and it isn't possible to very easily just like pull that data off and attempt to decrypt it or to sell the phone, which is good. Yeah, that's true. However, I'll read this out actually. Way less worried about a thief erasing the data and using the phone than someone using it with my data. Full disk encryption defeats this. Locking your bootloader only protects against like an evil maid and somebody wiping a device. That's very true. However, without a locked bootloader, if the bootloader is unlocked, then somebody can very, very easily flash a boot image and boot up the device into a state where they can essentially like read all of your encrypted data off, and then on a much more powerful machine, they could have a go at cracking that data. Whereas with a locked bootloader, that isn't possible. They wouldn't be able to read your encrypted data, and so they would not be able to crack it so efficiently. They would have to do it via the touch interface, which should be slower and can impose like lockouts and stuff, making it basically unfeasible to crack your data. So locked bootloader is still more secure in that sense. All right, so where were we? Charging-sdl not found. Yep. Interacting with the initramfs. Here it is. I ended up editing this wiki page yesterday because this mount boot partition now actually takes the mount point as a compulsory argument, whereas it did not before. So I've updated that. Also, this used a variable which isn't set, whereas just using an asterisk, a wildcard works fine. Fantastic. So now we should have charging-sdl. Ooh, there it is. It works. So why didn't it work? Uh-oh. Was it the font? Font path? All right, why don't we try doing some of this stuff manually then? So what if we set -x and then start charging mode? Uh-huh. Oh. Very fun. Unexpected. Oh, well. Okie dokie. What's the font path then? Looks good to me. Proc command line value. Oh, for charging on this device? Fantastic. We will have to drop that in VS Code. Oh. Mode. Oh, yeah, this is a normal boot. I think it'll be Android boot.mode equals charger for us. Alrighty. Where were we? Yeah. So charging-sdl PCF font path. Alright. Otherwise, it does the show splash. Cool. Of course, we are not running it with the environment variable for doing we're using DirectFP. We shouldn't be. Yeah, the font path is not. That's fun. Yeah. In normal boot, it will abort that grep. Perhaps you missed so we booted it. It displayed the charging error splash screen saying that charging SDL could not run, basically. I suspect it's because it was running with DirectFP. So where's here we go. SCL video driver. Oh no. I've killed my shell. How have we done this? There we go. Font path. We need to set this again. What's in here? Yeah, why is there? Oh. Oh, okay. The trading 24 is intentional. Because it's the font size. Yeah, can we schedule for a rewrite? I assume it would be nice to have a device info variable for OLED displays, because charging SCL has that -O option for OLEDs, but it's unused here. All right, so we have a font path. Now we want to do this. And this. Ooh, failed to open font. I think you're right about the trading 24. Fancy new lib. Cool. That sounds good. Yep. Font path was screwed. What's going on there then? Oh. Print $3. Well, bum. Oh. Ooh, okay. Proc bus input devices. Our power button is input 0. So why is event 0 not suitable? Is it just gonna chill? Oh. Oh, fantastic. It is using DirectFB, of course. Key power 1 pgrep? I don't fully understand this. Oops. Hey, fantastic. Charging-sdl is go. With just a little bit of lag. You are just meant to reuse double quotes for shell, like in here, aren't you? And it's like totally fine to do that. Whilst I wait for stream to catch up with you, I'm gonna go pee. That's what I'm gonna do. So, there you go. All right, I'll be right back. Mic was muted. Okay, so charging-sdl does work, but we need to set this environment variable. OSKSDL has it set, right? Yeah, here we go. Fantastic. So, OSKSDL, we do this stuff. Does this get cooled in here? Yeah, it does. So why doesn't start charging mode get cooled? They just run it? Great. Oakley dokley. This one's for you, Martin. I think charging-sdl is just missing some features that OSK still has, like KMSDRM. So it doesn't look like we'll be able to get that working immediately. Oh, well, you know, we can just add a wrapper function like this, can't we? Caleb Flanders? How big is my stream buffer? Because I suspect it's quite a lot of seconds. It does charge just as fast on the error screen. That is true. Let's see. Go live. Well, yeah. Sorry, the other Oakley dokley. I didn't say that, did I? Oh dear. I sure hope not. The only spare monitor I have for actually like making sure stream is alive is this TV that the landlord mounted on the wall up here. It's a bit of a pain. So like, yeah. You know what I'm saying. So cool. We found work to do. We found postmarketOS work to do. This is fantastic. This is what we are here for. Charging SDL KMSDRM. Sweet. So where are we? We need to go into the MK initramfs functions. Really? Line like 4. Oh, init functions, of course. Here we go. Start charging mode. So for this, we like do fun things with like one would think that these should just be set globally once rather than specifically for charging SDL and OSK. Yeah. However, you're never gonna run both on the same boot, are you? Yeah, that ain't too good. Well, it's not good, but words are beginning to fail me. So SDL video driver, KMSDRM, we basically need to grab that and in here. Support devices using KMS. Fantastic. And that should basically be it, other than this font path. What is this $3? Because this isn't cooled with any parameters. So is it just wrong? Yeah, keyboard font. Okay, so it matched both. So see here, keyboard font. There's keyboard font and keyboard font size. So we want keyboard font equals. I think that's what I want. Not sure if this \s is okay, but orc space. No. Yeah, I haven't really used orc, to be perfectly honest. Oops. PM bootstrap checksum postmarketOS mk initramfs. Cool. So 2 birds with 1 stone. With any luck, we now grep orc the font path properly. We're gonna get hit by shell check because of this when we go make the commit. Let's go check that now, shall we? var is referenced but not assigned. Yep, okay, we are just gonna need that. That is because this device info variable is defined when you source device info, which we just assume is, because yeah, fantastic. Run this checksum again. PM bootstrap builds postmarketOS mk initramfs. Okay, that was quick. That was very cool. Oh, whoopsies. Oh, of course. We haven't bumped the version. We'll have to do that. Build again. Package not. Oh, fantastic. Okay. Sweet. We have built mk initramfs. We can now PM bootstrap. I think if we just run the flasher, it'll run mk initfs, right? Here we go. What are we doing? Oh. Yeah. Dependencies needed to build mk initfs. Just copy paste all the linter disable lines and you're good. Yeah. Love it. Better to have shell check than to not. I recently spent a very long time adding shell check to all of my shell scripts and tools and stuff that I use for postmarketOS. I'm actually pretty chuffed with that because I also added CI for it. So down here we have this, where is it? It's here somewhere. There it is. We have these CI scripts. And these are pretty cool. So shell check, shamelessly inspired by the postmarketOS PMA post shell check script. I believe I caught a bug and didn't report it. I don't remember what it was. Sorry about that. Well, it's fine. It's fine, it works. So it checks for all .sh scripts and will run shell check on them. And then if you've specified custom files in a like GitLab CI variable, then it will check them too. I also created these GitLab CI templates. So this preamble specifies the scripts repo, which is this, and we'll clone it to a temporary directory, install shell check and git, install shell check, install git, and then git clone this repo and cd into this repo. So then you can just run shell check, and shell check will go into your project directory and do all that. Oh yeah, I think the postmarketOS shell check script does a lot of guessing to figure out, like, it does all of this, and there might be a specific need for this, but you can just, like, there's a CI variable for the project directory, which might be more suitable. Yeah. I have no idea. So that's that. So what this means is that where I want to use CI, for example, in the installer here. So I have shell check CI. So in my GitLab CI, this is all I have to do. Set the custom file. We want to run it on the actual like update binary. And then I just include these two templates, the preamble, which will configure it to clone the CI scripts, and then shell check, which runs shell check. And that is it. It's just that simple. Run shell check. So yeah. That's fun. Little detour. And we are done. We have flashed the boot image. I've forgotten what we were doing. Charging-sdl, it should work now. That's what we're doing, but we have a debug shell. Fantastic. All right. Power off. How's that? Is that gonna work? There we go. Okay. Let's see what happens. Debug shell is active. We should be able to do PMOS. Oh, right. Proc command line boot mode charger. There we go. So, yep. PMOS continue boot kicks us off, and we should get charging-sdl unless we bypass that because of the debug shell. Nope. There we go. Charging-sdl fixed. Oh. Okay. Great. Instead of a black screen, it's postmarketOS loading. I think that's because of the debug shell. Shell check does pull in a lot of dependencies. It's written in Haskell, I think, or at least depends on Haskell libraries. So you need like lots of Haskell libraries on your machine to have it, which you may not want. Oh, yeah. Damn. We've been streaming for almost 3 hours, I think. I reckon we'll make a merge request for the charging-sdl, and then I'll have to go and cook because I'm getting hungry. We're done. We're done. It does like to get stuck building that extra partition, but that's okay. Oh, now we do it all again. Oh yeah. MK initramfs just runs whenever you do anything. But that's okay. Well, hey, the charger like driver module just kind of worked, which is nice. It is again like super cool to just kind of see that stuff kind of just works. Like we did good. I think this has been mostly productive, despite my rambling. Let's power off, and then yeah, running export after install. Yeah, it takes a while. It'll take even longer now because we gotta copy a bunch of other stuff now for like charging and OSK. Hey, here we go. All right, so last thing, it does this. Martain, maybe you know, is it expected that it just displays a loading screen instead of like a black screen when charging? I'm gonna call it a win. I think I'm gonna call it a win. Has Snapdragon 845 best mainline support nowadays? I don't know. Yeah, Snapdragon 410 is probably like best, most polished. 845 still has like lots of fun quirks that just nobody's fixed. For example, there's some like DMA or like demux driver. It's been a while since I looked at it. There's just some random driver that crashes or when it goes into suspend. Kills your things. So that sucks. I had a look at fixing it. I think actually somebody's fixed it. Again, I haven't looked in a while, but yeah. Currently, I can tell you that Linero are quite fond of Snapdragon 845. They use a Snapdragon 845 dev board for testing for their stuff. But yeah, so kernel side, they're working on it and fixing bugs and stuff there, for sure. And the like larger like framework work that they do, so like power management and stuff, they test on 845 dev boards. Yeah, so it would be good to get charger driver going along with our kind of rudimentary fuel gauge driver, but you know, it's lots of work to build that. Certainly something that I'm interested in though. You haven't used the charging mode. Well, crap. I think the documentation said, I'll read this out for you. It doesn't actually say. Doesn't say what it shows. I would assume it would be a blank screen instead of postmarketOS loading. But so be it. Ugh. All right. That's absolutely fine. Yep. I will not lie, having to copy paste commit messages from the OnePlus 6 to the OnePlus 6T is a royal pain. Didn't need to force push, but that's okay. All right, we will stash these changes. We'll check out. So those changes were just the adding the fuel gauge driver to the initramfs so that we can like charging-sdl can actually read the battery stats. Yeah, so now we'll check out the master branch, make sure we're up to date, and what was the, yeah. So now we'll recheck out charging-sdl based on master, because we don't want to carry around all those like SMA45 like OnePlus 6 commits too, because this merge request is completely unrelated. So now we can get slash pop. We bump the version here, and charging mode. So yep, if it's Mesa, then do that. Blah blah blah. I think we are good. There we go. We will stage our changes, and then postmarketOS, mk initramfs, fix charging-sdl for chemist DRM devices. All right. Has OSK-SDL. Check for Mesa support and set SDL video driver in that case. Fantastic. SCMA45, charging-sdl KMS DRM. There we go. Click this link and we will open a new merge request. Oh, there is another fix in here actually. Can we include that in the same commit? Charging mode isn't a thing on the Pinephone. Yeah, I guess so. You'd need a bootloader to implement it. And I guess most people just don't really care about it. Quite happy to just have the phone boot, I suppose. Pipeline failed. Alrighty. So. Keyboard font and keyboard font size from osk.conf. There we go. Supports KMS DRM, however, it was never being enabled. add a check and set, what is it, SDL video driver for devices that use Mesa. Fantastic. Might have to split those commits, but we will worry about that all the time. Something frame buffer leftover. Not sure I follow. All right, let's go figure out why 2088 is failing. I think I just need to go and yeah, so these packages that I moved, it gets kind of confused about moved packages and wants me to bump the package versions, even though that is not necessary. Oh. Oh, the PMOS logo when the screen turns off. So right here. Yeah, it is a frame buffer. It's a frame buffer set up by the MSM DRM driver, not the frame buffer leftover from the bootloader. That frame buffer, we just ignore now. You can like add it to the device tree and use it, which is what I did for early development, but the MSM DRM driver supports frame buffer device emulation, where it creates its own frame buffer, which we use instead because it works. Whereas using the one set up by the bootloader, I believe it actually just gets destroyed. So yeah, don't know the details there. Is backlight control missing in initramfs? Good question. I don't know. That is very possible. It's possible that it is. Jimmy can't tell that. All right, I will check. I believe it isn't. I'm not sure why it would be. I'm not sure if with the frame buffer device backlight control even works. I think it would, because we're still using the panel driver. We're just using a frame buffer to drive it instead of GPU. So yeah, we will soon see. So my half-baked, mostly baked solution to streaming my screen. So this monitor is actually 4K, but you don't see all of it. So you only see about, well, down here is about 2/3, 3/4 of the screen. It's slightly more than 1080p. So there's a little bit of weird upscaling going on there. And then I'm just kind of making fonts bigger. Hopefully it isn't too horrific to read. I think somebody would surely have pointed it out if it was. I can make this font larger. Uh-oh. VS Code has just locked up on me. Wonderful. But yeah, so this seems to mostly work. Let's go PM bootstrap flasher kernel 5 head. Hope you aren't talking about my head. Ugh. How long have we been going for? Font size is okay. That is good. That is good. This doesn't even give me a time. Oh, 3.5 hours. Jeez. All right. That is flashed. Oopsies. We should get into. Yeah, I mean, the actual stream is only 1080p. I could like stream in 4K, but then anybody who doesn't have a 4K monitor wouldn't be able to see it, and it would just be a bit crap. So I could set the monitor to 1080p. This is true. I don't know. I like the space. That's all I have to say. I can maybe set it to 1440p and that'd work equally well, but yeah, I'm just bad. Why do you use VS Code, not VS Codium? That's a good question. I have used VS Codium in the past, and every time I have done so, less than a week later, somebody has asked me to live share with them. So that is why I use VS Code. Alrighty, sys class. Okay, watching? Nope. The backlight is there. So that theory is yeah. The real sad thing about having a like reasonably large 4K monitor, and then my like secondary monitor just being 1080p is the 1080p one is the one that I originally bought back when my only use of PC was to play games. So it's 144 hertz and it's real smooth. It's good, but the 4K one is just 60, so it just kind of sucks in comparison. I mean, it's fine, obviously. It's totally usable, but you know, I don't know who's seen the price of 144 hertz 4K monitors. But yeah, no, thank you. It does mean that if I wanted to play games, I am either stuck with 4K 60 or like 1080p 60, or I have to go rearrange monitors because it's like it's way over there. It's not very good for like looking at for long periods. Neck pain, really. So the other monitor is 1080p 144 hertz and 24 inches. My main monitor is 4K and it's 27 and a half, 28 inches. It's good. I wish I had gotten a 32 inch because at 28 inches at like regular font sizes at 1x scaling, it's like just a tiny bit smaller than is comfortable. So I just kind of make do. But if it was like a few inches bigger, it'd be nice. I've seen people genuinely say that you should be buying like 42, 48 inch 4K monitors, because then you can combine them with 24-inch 1080p monitors and the like scaling is the same. The pixel density is the same. I think that's obscene because that's massive. Absolutely massive. And just not really what I'm interested in. Well, that's a total lie, but it would be a real pain to set up. Ultra wide is probably the future. I said it. Yeah, Wayland plus fractional scaling helps. It does. Although I never, when I was using Wayland, I had this same monitor set up, but instead of a PC, it was my laptop, which has AMD graphics, and that was great. But fractional scaling just made all the X windows blurry, and it was just crap, unfortunately. But yeah, ideally, that's a cool solution. If it like just worked, I'd love it, but yeah, it doesn't. Didn't work for me very well. Yeah, I'd love to buy a 48 inch. Like 48 inch, but ultra wide. Replace both of them. Have you ever run Windows setup at 640 by 480 on an ultra wide monitor? I have not. I find it amusing that Windows setup still renders at 640 by 480 by default. I have played CS. I haven't played CS in about a year properly, other than a few random games. So yeah. I bought this mouse because of CS, and then stopped playing CS pretty shortly after, which kinda sucked for the wallet, but you know, it is what it is. It's a good mouse though. Logitech, just to kind of, yeah. Yeah, CS is good fun, but you gotta be playing with the right people, really. I do suppose that charging-sdl is just missing the ability to do backlight brightness stuff, right? That's what I'd assume. So I guess it would be possible to go add to that like trigger happy config to, after charging SDL, set the backlight brightness to 0, and before it set the brightness to like max or half or something. But then you get into problems because, for example, the OnePlus 6, the brightness is a scale from 0 to 1023. But on other devices, it's like only 0 to 255 or 0 to 512. So yeah, someone else's problem, maybe him. What's this unresolved thread? Oh yeah. We'll resolve that, I think. Alrighty, well. Wide windows. What have we become? Thanks everybody for showing up. This has been a lot of fun, really. I definitely didn't expect this kind of this many people. That's what I'm trying to say. Appreciate you all. Oh, this is the wide windows. I see it. That's wonderful. Absolutely. There it is. Oh, oh dear. Wide windows. All right. Perfect. Thanks everybody for showing up. We'll try and make the next one a little bit sooner. There's a bit of a gap. I kind of moved back to uni and then had loads of coursework, but you know, it's exam study period now, so it's free time, right? Free time. All right. Fantastic. Oh yeah. Exclamation mark Discord. Sure. Let me grab a link for you. Oh, actually. Already got a redirect set up. Who needs discord.gg, right? Fantastic. Yeah. I will hopefully see you guys all again soon. Yeah, this has been a lot of fun. All right. I do need to go and cook. Yeah, good stream. If anybody wants to make a YouTube chat bot, it's fantastic. Cheeky. All right. Where do we go? We go up here. I will yeah. Talk to you all soon. See ya.